All right, so hello again, everybody. Welcome back to another lesson, another video for math grade 10. All right, the local system. Is the screen clear? Right? The writing part? All right. In this section, which is the fourth section, we are going to talk about a specific function under the title of natural logarithmic function, which is ln. And at the end of this section, we will deal with the equations including logarithm and ln, which is the real challenge for the students, as much as I know about my students and the other student as well. All right, let's talk about natural exponential function before diving deeply inside it. Recently, in the third section, we discussed about logarithmic function. Well, natural logarithmic function is a specific type of logarithmic function when the base is e. Whenever the base is e, of course, you know that logarithm has two parts, exponent and base. Whenever the base is e, we call it natural logarithmic function. As well as we study about inverse function in the beginning of this third section, we said that if two functions are inverse of each other, so domain of the first one is the range of the second one, and the range of the first one is the domain of the second one. So right now, let me just tell you that natural logarithmic function is the inverse of natural exponential function. What do you mean, Mr. by that? Well, here, let's just first of all read this that we have got in this slide, and the thing that I said, it's over here. So here, it is logarithm with base e. This is what exactly I said before some minutes. So whenever the base is e, we call it natural logarithmic function. The symbol ln used for the natural logarithm. Whenever you see ln, yani what I mean by the symbol, let me just bring my pen. All right. So whenever you see something like f of x equals to ln x, so it means it equals to logarithm with base e. Logarithm actually f of x equals to x. Sorry, it should be x here. That is something else. So whenever we have got ln, in fact, it means there is a logarithm with base e. Gosh. So right now, it's written that this logarithm has the same properties as the common logarithm base 10 and other logarithms. Remember, there was a table in page 123. We discussed about it a lot. And in this section, we will use it again. We will use what? The properties, 7 or 8 properties. And we studied like notes as well. So they will work as well as for like ln x. The same properties, we will use them for ln x. And of course, at the end, we will use them in order to solve equations that includes logarithm. All right. So here is the important part. ln x equals to logarithm x with base e. This is exactly what I wrote it here. Remember, x must be positive. So I might bring something like this. Logarithm negative 16 base 4 equals to 2. Be careful. Since it's written here, x, which is the exponent of the logarithm, should be always positive. We don't have negative exponent in the exponent part of the logarithm. That's why whenever you see such a thing, I might bring this one as a multiple choice in order to challenge you, as I already did it for my students. So, or any other teacher can bring this one. Logarithm with exponent, with negative exponent is impossible. Yani the exponent cannot be negative. That's it. Right now, this is the most important part of this section, I can say. F of x equals to ln x is the inverse function of the natural exponential function. What do you mean, Mr. by that? We had e, natural exponential function. Then we had ln. These two, since they are inverse of each other, they are going to kill each other. And what will remain? 1. So, not only 1. Like, for example, whatever is with this e as an exponent or anything else, that's going to stay. For instance, if we have ln e powered by x, so we are going to simply say that ln and e will kill each other. What will remain? X. That's it. Yani the meaning of inverse function is they will cancel each other out. Yani whenever these two functions are inverse of each other, when they are going to reach each other, they will kill each other. Just like e and ln. So in the upcoming, there is something important here. I want you to take care of it. Already we got familiar with the graph of the exponential function. This is the graph of exponential function that in section 2 we discussed about it a lot. The blue one. And the red one is the graph of ln function. Bash. So, since they are inverse of each other, let's just compare their domain and range, because that is again going to become a beautiful question. It can become a question in the exam. Like f of x equals to e powered by x, f of x equals to ln x. For e powered by x, domain was all the real numbers and range was from 0 to positive infinity. But since ln x is the inverse of exponential function, so of course their domain and range are going to change. For instance, domain here is all the real number. So since ln x is the inverse of this one, range is going to be all the real numbers. And as you can see in the graph, I'm talking about the red graph, it goes down to where? To negative infinity. And it goes up to where? To positive infinity. Therefore, up and down related to what? Range. So range is going to be all the real numbers. How about the domain? So domain is equal to the range of the previous function. What was the range here? 0 to positive infinity. So the domain of ln, which is natural logarithmic function, is going to be from 0 to positive infinity, of course, open interval. So let's just analyze the domain of the red graph. So the red graph from left to right, as you can see, it's from 0. It didn't touch 0 itself. So it's from 0 to, it goes to positive infinity, the domain. That's why here we will write domain is 0 to positive infinity. So they are like the opposite of each other. Domain of this one is the range of here is the domain of this one. Take care of this note, please. The next slide, we have got whatever we said right now. Well, domain of natural logarithmic function is the set of all the positive real number. What I mean by that, from 0 to positive, this is exactly what we wrote in the previous slide. And the range of natural logarithmic function is all the real numbers. So the range of ln function, that it is called natural logarithmic function, is all the real numbers. Try to make differentiation between these two. Domainy exponential is all the real number. Rangey natural logarithmic function is all the real numbers. Domain exponential function, range logarithmic function. Be careful. Alright, there are some properties that we need to take care of them. ln e equals to 1, because ln and e, whenever they see each other, nothing will remain. In fact, there is a 1 here, so only that one will remain. Whatever is with e, this is going to be the remaining part. For instance here, this is a very important one. ln 1 equals to 0. Just like we already studied, logarithm 1, no matter what is the base, equals to 0. We have got the same thing for ln. ln 1 equals to 0. And whenever there is an exponent, that exponent can goes behind ln. Or simply, we can say that ln and e kill each other. What will remain? N. So, as well as here, Dana, so e and ln will kill each other. What will remain? Only x. Tamam? So only whatever is with them will remain. Perfect. Dida, do you want me to call your name? So please, have a sit. No, you cannot go. Stay. Alright, write down this expression in simplest form. How are we going to, look, always the students have got problem with this. Whenever the question asks you to write it in simplest form, you don't need to find the value of x. But if it says solve it, you have to find the value of x. Right now, it just said that write it in simplest form. Well, simplest form, to write it in simplest form, we need to use the properties of logarithm. For instance, here, e and ln are going to kill each other. So what will remain? E and ln will kill each other. What will remain? X squared plus 1. Is it clear? The color? All right. How about here? ln and e kill each other. Only 5x will remain. But there is something interesting regarding to the third one. Be careful. Between e and ln, there is something. Well, there is a number. This number is supposed to be here in the exponent part. So basically, it equals to e powered by ln x powered by 2. Originally these 2 was here, but it came here. So we need to just take it back, bring it back to its own place. Right now, just like we already said that E and ln will cancel out each other. What will remain? X powered by 2. I did not ask you find the value of x or solve it. That's why leave it. X squared, that's it. That is the simplest form. Next one, E and ln will kill each other. What will remain? Negative 3, x powered by 2. And finally, not finally, this one as well, E and ln will cancel each other out. What will remain? 0.6x plus x squared. So that is the result after simplifying. This is the story of the third question. It has the same story. Let's just find it out. There is something interesting regarding to it. So e powered by 1 over 2 ln x. We said that if there is a number, we need to just bring it back to the exponent part. So it's equal to e powered by ln x powered by 1 over 2. This 1 over 2 will come back to its own place, which is the exponent. So right now, e and ln will kill each other. What will remain? X powered by 1 over 2. So this is the final answer. I will accept it, but in a kind of like examination that it is like kind of formal and just like Wizari, ministerial examination. Whenever you see such a result, you must turn it to square root, because the note is saying like this: if the exponent of something or of a number is 1 over 2, so that is equal to the square root of that number or that variable. For instance, right now the square root is what? 1 over 2. So the final result after like simplifying, and in the simplest form, equals to square root of x. Basically, let me just make it simpler. Whenever the exponent is 1 over 2, it's going to become the square root of that base. That's it. For example, let's say 3 powered by 1 over 2, so it's equal to square root of 3. 100 powered by 1 over 2, it equals to square root of 100, which is 10. That is the story of exponent of 1 over 2. And I hope that it's clear by now. Let's see what we have in the next slide. Okay, some more questions, but different story, different properties. Not actually for the first one and the second one, but the third one is interesting. So ln and e will kill each other. What will remain? 3x minus 5. Easy, right? Here, again, this 6 is going to come here, come back to its own place. So it's going to become e powered by ln, x powered by 6. These two are going to kill each other, Salah, right? What will remain? X powered by 6. All right, but the last one is interesting, and I would love to bring this type of question in order to play with my students' mind. Well, regarding to the last question, we need to know that whether we can simplify any of these logarithm or not. For instance, logarithm 2 with base 5, we can't do anything with 2. Like you might say, okay, it's 1 times 2, a 1 times 2. What are you gonna do? What are you gonna do with 1 times 2? Nothing. So it's just gonna stay the same. Log 2 5 plus. But with 50, we can do a lot of things. Like for example, Danas might say that 5 times 10. Correct. But like more appropriate than this, Muhannad might say that, okay, mister, we can just turn this 50 to 25 times 2. Why 25? Because 25 is a perfect square numbers. Dealing with perfect square in order to simplify, it's easier than dealing with some numbers that they are not perfect squares. For instance, 5 and 10, none of them are perfect. But 25 times 2, they are perfect. Check it with it, see whether it is better or not. So, I will change logarithm 50 to 25 times 2, base 5. Got it? F. For multiplication, what do we have? We will add. So it's going to become log 25 base 5 plus Basha log 2 with base 5. And originally, we have got one more log 2 with base 5. Now, as you can see, Dan, as these two are the same thing. These two looks like they are exactly the same. What did we do already for x plus x? Yani 1x plus 1x equals to 2x. So imagine this one is x. 1 logarithm 2 plus 1 logarithm 2, so it's equal to 2 log 2 with base 5. So these are done. How about logarithm 25 with base 5? Well, everybody knows that 25 can be written as 5 powered by 2. Now there was a property, it says that in page 123. If these two were the same, so the result equals to the exponent. What is the exponent here? 2. That's it. This is the final result. You don't need to go anymore. And I hope that you did understand it. We have more examples, if I'm not mistaken, regarding to this, but this time we are dealing with equations. So focus on this one, please, a lot, because this is what we are afraid of it as teachers. Always students have got a problem with equations, including like logarithm and ln, but it's actually easy. Let's just deal with some of them here. 5 powered by 2x equals to 125. Well, the purpose of studying equations or doing equation is to just find the value of the unknown that we have. For example, our unknown here is x. So clearly everybody knows that 125 can be written as 5 powered by 3. Why, Salah? So 5 powered by 2x equals to 5 powered by 3. Bases are the same. Exponent must be the same. Equalize them. So 2x equals to 3 divided by 2 divided by 2. Finally, x, which is what we are looking for, is equal to 3 over 2. Some student might say that, teacher, can we write 1.5? Definitely you can write it. Both of them are acceptable. 3 over 2 and 1.5. So x is equal to 3 over 2. That is the solution of the first equation. The second one, again, ask yourself, can we write 10 as a power of 6? Absolutely not. So for such a question, we need to use logarithm. We need to take logarithm for both sides. Let's just do it. Take logarithm, take logarithm. But whenever you take logarithm, of course, you should think about its base. Randomly, you cannot make a random base for the logarithm when you take it. All right? So always, whatever is this number, take it as a base. Make the base equals to that number. So right now here is 10, right? So the base is going to be 10 here. Why do we do that? In order to cancel this side. Logarithm 10 with base 10 equals to 1. So right now we are going to have logarithm 6 powered by x base 10 equals to 1. This exponent can come behind. Can it? Of course. So it's going to become x log 6 base 10 equals to 1. What did we do here? Whatever what was x, we just divide both sides by that. What do I have with x right now? Log 610. So divide both sides by log 610. Log 610. This is going to cancel here. What will remain, Roger? X equals to 1 over log 610. That is the final result. Whenever we cannot write one side in terms of the other one, we need to take logarithm, just like this expression. So the difference between these two, we could write 125 as a 5, but here we cannot write 10 as power of 6. That's why we need to take logarithm. Take a look at the third one. I need to erase this one in order to have enough space to deal with it. So the third one, we have a like plus between these two logarithms. When we have plus, we need to turn it to multiplication. All right. So turn these two logarithms to one logarithm. For x times x, I'm pretty sure you know it. It's equal to 4x powered by 2 because x times x, x2. Base is not over, so whenever we have no base, so base equals to 10. 100. So remember the common rule that we use. We call it right hand rule. Use it. 10 powered by 100 equals to this. So 4x squared equals to 10 powered by 100. Divide both sides by 4. Divide both sides by 4. What will remain? X squared equals to 10 powered by 100 divided by 4. In order to remove square, what do we need to do? Take square root. This one is going to go with this one. Roger, square root of 4 equals to 2. How about this one? Remember we study a note, Danas. We said that a powered by m, when the index is n, we can just take out this from the square root in this way. A powered by the power inside divided by the index outside. So m over n. So the index of square root is 2. 100 divided by 2, 50. So it's equal to 10 powered by 50. That is the result. Tamam? So the next one, we have got negative between our logarithms. So for negative, we need to turn it to division. Dida. Log x divided by 4, base is 3, equals to 2. Right hand rule. 3 powered by 2 equals to x over 4. 3 powered by 2 equals to x over 4. 3 powered by 2, 9. Denominator 1 equals to x over 4. What are we going to use here? Cross product, or according to some students, butterfly. So x equals to 4 times 9, 36. Am I correct? Perfect. The last one, which is the most important one, my favorite one. I love the last one, by the way, and I want you to learn it. How are we going to solve it? All right. So this one. Why it's my favorite one? Because we have got quadratic equation, and it is important, honestly. So logarithm, let me just rewrite it. X squared plus x minus 1. Base is not there, so base is 10. Equals to 0. Right hand rule. So 10 powered by 0 equals to this. 10 powered by 0 equals to x squared plus x minus 1. Alright, 10 powered by 0 equals to 1. Be careful. Some people are writing 10 or 0. Not correct. Number powered by 0 equals to 1. Now, to solve quadratic equations, we need to make one side 0. Move everything to the other side. To the side of the x squared. Basha, x squared is in this side. Move this one here. So it's going to become negative 1. So we are going to have x squared plus x minus 2 equals to 0. Now, first semester, we used a rule, quadratic formula. It was negative b plus minus square root of b squared minus 4ac over 2a. A is the coefficient of x squared. B is the coefficient of x. C is the constant number. Let's just substitute it. Negative 1 plus minus square root of 1 squared, 1 minus 4 times 1 times negative 2 over 2 times 1, it's equal to 2. That's not 21, 29. Alright, so negative 1 plus minus. This negative times this negative, positive. 4 times 2, 8. 8 plus 1, 9. Square root of 9, it's equal to 3 over 2. One time go with the positive, one time go with the negative. Negative 1 plus 3, 2. Divided by 2, that is one result. Negative 1 with negative 3, negative 4. Divided by 2, negative 2. That is the second result. And I hope that this is clear, inshallah. Next slide, again, we have got a bunch of questions that there is a different story about each one of them, but still it's easy. Right hand rule. 10 powered by 5, Salah equals to x minus 1. We need to find x, make x alone, so move this negative 1 to the other side. Simply x equals to 10 powered by 5 plus 1. 100,000 plus 1, 100,001. How about this one? There is what? Negative. Turn it to division. Log x minus 14 over x, base is 2, equals to 3. Right hand rule. 2 powered by 3 equals to here. 2 powered by 3 equals to x minus 14 over x. Cross product. 2 powered by 3, I got a C. 8. Instead of this, I will write 8. So 8 times x, 8x. 1 times x minus 14, x minus 14. Move this x to the x side. The beta minus, right? So 8x minus x, 7x equals to negative 14 dida. Divide both sides by 7. Why 2? by 7. So x equals to -2. You might ask me, teacher, is this a solution? Absolutely not. Why? Because if you substitute it here, it's going to be -2. We said that exponent of the logarithm should not be -2. Is it okay?
It's blue.
Okay. Perfect. 25 is nothing. So you're not going to get bored. The last one. Should I leave it for you? Right hand rule and simplify. So, or there is an easier way. We said that if there is an exponent, Salah, it can come behind the log. Right? Properties say that. 4 log x base 4 equals to 8. Divide both sides by what? By 4 by 4. What will remain? Wait a second. Logarithm x base 4 equals to 2. Right hand rule. 4 powered by 2 equals to x. So x equals to 4 powered by 2, which is 16. That's it. You may just... Alright, let's just solve these questions that left. So the first one, there is a logarithm, there is an equation. Logarithm x squared plus 10x plus 25 with base 10 equals to 0. Let's just do it. Right hand rule. So we are going to use the right hand rule. It equals to something like this. So it says that 10 powered by 0, 10 powered by 0 equals to the exponent, which is x squared plus 10x plus 25. So right now, let's see what we have here. 10 powered by 0 equals to 1. If 1 goes to the other side, it's going to become -1. So finally, we are going to have x squared plus 10x plus 24 equals to 0. So we have a quadratic equation here. We can use the quadratic formula, -b plus minus square root of b squared minus 4ac over 2a. So -b, -10 plus minus square root of b squared is 100 minus 4 times 1 times 24, 4 times 1 times 24 over 2 times 1, 2. So right now, let me just change the color. So we are going to have -10 plus minus 4 times 24, it's 96. 100 minus 96 is equal to square root of 4. Square root of 4 chandaka, 2. So it's equal to 2 over 2. Now one answer is going to be -10 plus 2, it's -8. Over 2, it's -4. -10 minus 2, -12. Divided by 2, it's equal to -6. That is the results of the solutions of this equation. How about the next one? We had such a question in the previous slide. Can we write 7 in terms of 4? Absolutely not. So take logarithm for both sides. Log with what base? With base of 7. We said that whatever is this number, turn it to the base. So this side is going to become 1. That was a property. If the base and the exponent were the same, the result is equal to 1. So simply we are going to have log 4 powered by 2x base 7 equals to 1. Now these 2x can come behind. So it's going to become 2x log 4 7 equals to 1. So finally we need to make x alone. So whatever is with x goes to the denominator. Divided by 2 log 4 7. Divide the other side by 2 log 4 base 7. This is going to kill this. This one is going to kill this one. Only x will remain. So x equals to 1 over 2 log 4 base 7. This is the answer of this equation. And finally, simplify this one. So if you simplify this, logarithm 48 with base 4 minus 3, logarithm 3 with base 4. So this one we can't do anything with it. Alright? But logarithm 48, I know you might say that since there is negative, let's just divide them. But it's a numerical example, so we can simplify the numbers first, then we can use the properties. So 48 can be written in different ways. But the best way is, as I already said, I try to look for a perfect squared. All right, numbers, factors. So we can say 16 times 3 base 4 minus 3 log 3 base 4. We can't do anything with this, so just keep it. But 16 times 3, so it's going to become log 16 base 4 plus log 3 base 4. Why do we plus? Because there is multiplication here. So for multiplication, we need to use addition between these two logarithms. We will just separate them. Minus 3 log 3 4. So right now, these two are the same. The coefficient of here is positive 1, here is negative 3. So 1 minus 3 is equal to negative 2 log 3 base 4. How about this one that remains? So 16 can be written as 4 powered by 2, right? These 2 is going to come behind. Or if the base and exponent are the same, the result equals to the exponent, which is 2. So finally, it equals to 2 minus 2 logarithm 3 with base 4. This is how we simplify and solve that one. Finally, that was all the questions in this section. Of course, it's in my plan to record another lesson just regarding to solving equations of logarithmic functions. I will see you in another video. Take care. Bye-bye.